In this question, we'll review quantum numbers. Let's imagine that we have an aluminum atom. Question A asks, according to its position in the periodic table, what is its highest occupied energy level? Let's go to the periodic table and find aluminum. Aluminum is located on the third level, element number 13. We'll label the levels. We can see that aluminum is on the third row, which means its highest occupied level is level 3. Let's indicate that near our question. Question B asks, in that level, what are the possible angular momentum values, or L values? Now, our L values depend on N. The possible values for L are between 0 and N minus 1. Now, our N is 3, therefore N minus 1 would give 2. So the possible values for L are 0, 1, and then we stop at 2. We use only whole numbers starting from 0. And we stop before we reach 3. Question C asks, if L was 1, what are the possible magnetic values, or ML? Well, ML depends on L. Our possible ML values are between negative L and positive L. Now, we were told in line 3 that L is 1 for the purposes of this particular part of the question. Therefore, ML can be anywhere between negative 1 and positive 1. However, any number in between negative 1 and positive 1, as long as it's an integer number, can also be ML, so we must also include 0. But remember, we can only use integers here. So we'll say our possible MLs are negative 1, 0, and 1. Part D asks us about MS values. Now, the MS values stand for spin, and those can only ever have 2 values as long as we are talking about electrons. They can either be positive 1/2 or negative 1/2. It doesn't make much of a difference which one we select, as long as we use one or the other. The only provision here is that 2 electrons that are sharing the same orbital must have different spin values. So therefore, if you have an orbital that has 2 electrons, one of them must have an MS value of positive 1/2, and the other must have an MS value of negative 1/2. However, which one we designate positive 1/2 and negative 1/2 is completely arbitrary. One is just as good as the other as long as they're not the same. Let's take this concept one step further and determine if these sets of quantum numbers are valid. The quantum numbers are always given in the order N first, then L, then ML, and then MS. We'll check all 4 numbers, starting from N and working our way across. In part A, we are given that N equals 3. Any number for N is fine as long as it's a positive integer. Now, 3 is a positive integer, so this works. Our second number is L. We were given that L was 2 for part A. Our requirement here is that it must be between 0 and n minus 1. n minus 1 is 2, so that's a match. That fits between 0 and n minus 1. Our ML is given as 1, and the requirement for this must be between negative L and positive L. Now, our L is 2, so this can be anywhere between negative 2 and positive 2. But this includes negative 1, 0, and 1 because those numbers are all between negative 2 and positive 2. 1 is on this list, so this checks out as well. Now we are given an MS value of 0. The requirement for MS is that we must be negative 1/2 or positive 1/2. But the 0 we have here does not match. Therefore, we say this first set of quantum numbers is not valid. And we say it's not valid because of MS. Now, let's check question B. Question B gives us an n of 3. This is fine because this is a positive integer. We are also given an L of 2. We note that L is definitely less than n, and it's a whole number, it's an integer, and it is between 0 and n minus 1. So this works as well. Now remember, ML must be between negative L and positive L. We were given an ML of negative 2 here. And this matches our L. This is between negative L and positive L because our possible ML values are going to be negative 2, negative 1, 0, 1, and 2. Negative 2 is on the list, and so it matches. We are also given an MS value of negative 1/2. Now MS can either be negative 1/2 or positive 1/2, and so this number is fine. So we'll say configuration B is valid. Now let's go on to configuration C. We're given again an n of 3. Since this is a positive integer, this works fine. We're also, however, given an L of 3. The L must be between 0 and n minus 1. But n minus 1 is equal to 2, and so this 3 we have for L is too high. Based on that, we can stop right now and say that this configuration is not valid. The reason it's not valid is because the L is too high. Let's also do configuration D. Configuration D gives us an n value of 3, an L value of 0, an ML value of 1, and an MS value of 0. Now, n is still a positive integer, so this is fine. L must be between 0 and n minus 1. Therefore, 0 is fine, 1 is fine, and 2 is fine, and 3 would not be. But since 0 is on this list, this is okay. ML must be between negative L and positive L. But since our L is 0, our only possible ML value is 0. 1 is not on the list. Therefore, this is not a valid configuration because ML is invalid. We could also look ahead and see that the MS is also not valid. But since our first error came from ML, we can stop there and say that the configuration is not valid by reason of ML.